Alright, welcome. We are looking at lesson 100. 100. We've gotten to lesson 100 here, and we're looking at constructing geometric models. So we're going to continue to talk about some geometry. Remember, we talked about geometric solids the other lesson. So after you've done the warm-up, we can come to this part of the video, and we'll look at today's new concept as we look at different models for these geometric solids. Alright, lesson 98, as I just mentioned, we talked about different geometric shapes, such as triangles, rectangles, and circles that have two dimensions, length and width, but in order for them to have depth, we need to have it three-dimensional. So that's where the geometric solids come in. So anything that has just area, that would be flat. Anything that takes up space, that would be three-dimensional. So the following are just flat objects, or also called plane figures. Plane means it's on a flat sheet of paper. So square, triangle, circle, those are all flat. You can draw them on a piece of paper, and those are called plane figures. If they take up space, meaning they would be three-dimensional, they would come off of the page. We can still draw them on a page, but we need to kind of use some dashed or dotted lines in order to give it a little bit of depth, so our eye can kind of see what it looks like in three dimensions. So these shapes are called geometric solids, as we talked about last lesson. Cubes, pyramids, cones, and these solids have three dimensions. They have length, width, and now the third one, depth. Okay, before we just had to talk about length and width. Now we have to talk about length, width, and depth, three dimensions. So these solids are not going to just be on a sheet of paper, on a plane. They're not confined to a plane. They are three dimensions. So we have to draw them with a little bit of skill in order to tell our eye, kind of trick our eye into looking at it and seeing it as a three-dimensional object. So the cube right here, as you draw a cube, you can draw a square, and then put some edges at an angle and draw four edges parallel to each other, and then on the back side you're going to complete the back square, and here you're going to put in dashed lines because those are, and this one should be dash 2, sorry, those are edges that you can't see. And then that's kind of telling your eye that it is a three-dimensional object. The dashed lines are the ones behind in the back of the object. So that's done here for the cube, the pyramid, and the cone. So here's what you're going to do in today's lesson. You're going to cut, fold, and glue, or you can tape them, paper patterns to construct these three-dimensional models. A cube, a pyramid, and a cone. It says here, before making the models, by the way, a model is just a representation of something that we know is in real life. Okay, we're trying to take something from the real world and use a model to represent it. So before making the models, consider the shape of a cereal box. A cereal box would be a particular one of these geometric solids. It is a rectangular solid. Okay, and that is every side of a cereal box is a rectangle. If you empty the cereal box or some other type of box, then you'd be able to fill that box because of the space inside, and that's what makes it three-dimensional. It's a rectangular solid, and now it's going to take up space and can be filled. That volume can be filled. Okay? Let's look at these 5 questions concerning a cereal box. A closed cereal box has how many panels? Well, we called those faces before, so it's going to have 6, a front, a back, bottom, a top, right, and left. I just said, what could we use for those panels? Faces. That's the term that we used before. Okay. Without a mirror, what is the largest number of panels that can be seen at one time? Well, let's go up here to this diagram. If you look at this one here, maybe if you turn the cereal box a little bit to the side at an angle, maybe you could see 1, 2, 3 at one time, and then there are going to be 1, 2, 3 that are hidden. Okay, but you can play with it, get out a cereal box and turn it around and see if you can see more than 3 at one time. Two panels meet at a fold or a seam. We've been calling those, from last lesson, we've been calling that fold an edge. It has how many edges? Well, it has 1, 2, 3, 4, 5, 6, 7, 8, front and back, and then 1, 2, 3, 4 that are connecting the front and the back, so that's a total of 12. 3 edges meet at each corner, and remember we called those vertices. Vertices is plural, or a vertex. So there are 8 vertices on a cereal box. If we tape an empty cereal box closed and cut it along 7 edges, we can flatten out the containers shown below. So if you were to take that box and cut it and then be able to lay it flat, you would see, you could lay it flat. Here's the front and back, the 2 sides, the top and the bottom. Okay? And this is going to be useful because eventually what you're going to be asked to do is you're going to be asked to find what's called the surface area. And that's the area of all of the panels or faces added up. So you can think of it, if you take a 3-dimensional object and then you cut it and are able to lay it flat, now you can talk about the area of all of this here. And that would be what's called the surface area of your box, the area of all the faces added up together. Not the volume is the space inside, but the surface area is the area of all of the faces. So these 6 rectangles form the panels or the faces, and we can use this to also construct a cube, a pyramid, and a cone. Okay, just the same idea, not the same structure, but the same idea is we use this idea to think about a cone, a pyramid, and a cube. Okay? So here's the activity. What you want to do is look at the activity masters 18, 19, and 20, and then get some scissors and maybe some tape and cut out the patterns. Fold the paper along the edges, and then see if you can make these different models. Okay? So have fun with that. This whole activity, the purpose of it is just to get you used to seeing how these different geometric solids are formed, and also see how they're constructed. What makes up these geometric solids? What are the faces? What are the parts that are going to make up these different geometric solids? Because you're going to be looking at all those individual parts and using them in order to find the surface area. Okay? And after that, we'll talk about probably the volume of these geometric solids. Okay, after you're done with that, go on to the mixed practice and work through the 30 problems, and let me know if you got any questions.